Okay, so everybody please give a very warm welcome to Philippe. He's our security expert. Go ahead.
Wow, an applause just for showing up. That's a good start. Hi, welcome. I'm going to talk about something that all of you probably have encountered before. I'm going to talk about cookies versus tokens. I'm going to talk about why it's actually a kind of a weird choice you have to make. I'm going to lay out the options for you. To be fair, I'm not going to be able to give you any solutions. I will not be able to tell you how you can solve your problems. I'll be able to tell you what you need to take into account, and then of course it's up to you. It's up to you to decide what fits your situation and how you want to deal with these things. Let's get started. Let's start easy. I know it's security, everybody might be scared about it. Let's start about session management. Traditional server-side applications, I use server-side session management. So you have a first request to an application, server is going to generate your session object, assign an identifier, and essentially send that back in a cookie. Browser is going to store that for you, and whenever there's a new request going out, the browser will automatically attach that cookie. Server can expand that session object, will look it up, find your information, and decide how to handle that request. These things are used for authorization decisions, and that's essentially what we've been doing for the past 15 to 20 years. However, in Angular applications, things tend to be a bit different. So many people in Angular applications actually use a different mechanism. They use something called client-side sessions. And what that happens is the server still generates a session object, server still creates session data, but then packages the whole thing and sends it back to the client. The client stores this, typically in local storage or whatever, and whenever there's a request, the client application or Angular application is going to attach that information, send it back to the server. Server can expand that information, look at what's happening, make its decision, and then send the response based on that. And that's a new paradigm. There's a lot of things different here, and that's essentially what I'm going to talk about. I'm going to compare these two mechanisms. I'm going to talk about what matters there and the security considerations that you need to take into account. Before we start, a small word about myself. Carmen introduced me as a security expert. I give trainings on security, not only Angular security, but web security in general, but also specifically for Angular. I did a workshop here yesterday on a topic very similar to this, so some people here in the room were at the workshop, so they'll get a different view of what we talked about yesterday. I've also built an online course on security, which is freely available on the edX platform. The course closes actually in a week, but the content remains available in the archived course. So if you're interested in web security, there's a pack of videos there with a lot of information. And finally, I also organize a SecOpDev course along with a team, of course, and the SecOpDev course is a week-long course on practical security for developers, project managers, architects, things like that. We cover a broad range, ranging from web security to language security, .NET, identity server, cryptography, stuff like that. So if you're interested, check it out. And for now, I'm going to talk about session management in Angular applications. When we started out with the question, cookies versus tokens, as you will see throughout the presentation, that question doesn't make sense. And to me, when you talk about session management, I believe you should be talking or thinking about three distinct properties. The first property is the locality of the session data. You want to think about where you store your session data. You want to think about how you transport your session data. And you want to think about where you store the actual information, how you store it on the client. We're going to dive in each of these topics in a lot more detail in this presentation. I'm going to outline common mistakes that I see in applications. I'm going to outline the way you should be doing things and the things you should be taking into account. Let's start with locality. Like I said in the introduction, you have actually two very common mechanisms. You have some kind of server-side state and you have some kind of client-side state. So essentially, these things are traditional server-side state has disadvantages. One example is a stateful backend. You have sessions stored on the server, and that becomes a problem if you're building a scalable system where you want to add more backend servers. Then you have to think about things like sticky sessions or session replication, things like that. And that's messy. And that's why people, with the introduction of Angular applications, thought, hey, we can push this to the client. That's actually a lot better. No more state on the server, no more mess to deal with, and the client will handle everything for us. Sure. There's also a couple of drawbacks when you do it like that. If you want to list active sessions, that's easy with server-side session management, but really hard with client-side sessions, because you don't know how many active sessions there are until the client comes back to you, and then you know, oh yeah, that client still had an active session. So that makes it a bit a bit harder. Another one is revocation. If you want to revoke a session on the server side, that's easy. You just destroy the object and the session is gone. Client-side revocation is a lot harder. There's no way for a server to reach into your Angular application on a client side, on someone's phone, and destroy the session information there. So that's definitely one of the things that is harder and often overlooked when you're starting to move towards these client-side sessions. And maybe the most important one is integrity of the session data. If you store session data on the server in an object, it's implicitly trusted. There's no way for the attacker to modify that data on the server, except by, for example, hacking the server, but that's quite a big problem and a lot bigger than manipulating some session data. But on the client side, it's a whole different story. You see here, for example, the current user ID is stored in the session data. If you store it on a client and an attacker manipulates that into another ID and sends it back, if the server accepts that, you're in a lot of trouble. And that's why integrity checking is absolutely required if you are working with client-side session data. Fortunately, the mechanism many people use for that are Geotokens, JSON Web Tokens, and they come with kind of integrity protection built in. By default, a Geotoken, what you see on the left, is actually a representation of a Geotoken. It's a blob of base64 encoded data. And if you decode it, you actually get these three parts on the right. And the three parts on the right, the middle one is the payload. That's the data itself. That's essentially what you are sending to the client and telling the client to store for you. Keep in mind, this is base64 encoded. It's not encrypted. It's not because you can't read it that it's not easy to transform into something readable. So this is not encryption for the record. But what's really important is Geotokens come with a signature by default. So the server or the service issuing these Geotokens can sign them. And whenever they come back, the server or the backend can verify the signature and see whether the tokens have been modified or not. Of course, this requires that the only one being able to generate such a signature is the one issuing these tokens, but that's an implicit requirement that we are under here. So essentially, this sounds pretty good. Unfortunately, what often happens, or what we commonly see happening in applications, is that a developer forgets to check the integrity of a Geotoken, or simply thinks he's doing it correctly, but actually is making mistakes. Here's an example of a code snippet to verify or to decode Geotokens with the official Java library for Geotokens. As you can see, you get a token as input, you decode it, and you get the claims which you can use to make decisions. The problem is, the decode function that is being used there is actually not verifying the signature at all. It simply decodes the data from base64 to something readable, and it offers access to the data, but it doesn't verify any signatures. To get it right, you need to do it like this. And if you do it like that, it's actually a lot more complicated. You have to define an algorithm first. You have to initialize it with a secret, and then you can use that algorithm to actually verify the integrity of the token and get the data out of it. And this is something that actually happens in real applications. People make mistakes. People use the wrong library function to decode the Geotoken, which results in a vulnerable backend. If you get this wrong, anybody can supply you a Geotoken, and the backend service will accept anything. So anyone can start forging tokens and giving you a fraudulent token, thereby gaining access to your API. So this is it's a very brief overview of the consequences of the locality of session data. Even though in an image it seems like, yeah, it's almost the same thing. You have the data, and now you send it the data instead of an identifier. But in practice, this has a really big impact. And that's one of the first things I wanted to mention. Next up is the transport mechanism. So common transport mechanisms are cookies or the authorization header. So if you look at this, by the way, both mechanisms work perfectly fine with both client-side and server-side session data. And if you look at what's happening here, you actually see that they look very similar, but the properties of these mechanisms are extremely different. By the way, just to get an idea, who here is using cookies to access their API? Almost nobody. Who is using the authorization header? Almost everybody, yes. Why? Because it's the right way to do things in Angular, probably. It's because somebody told you need to do it like this. Well, honestly, I don't necessarily agree. It has advantages and disadvantages, and that's what I'm going to talk about here. Let's talk about cookies first. Cookies have been around for a really long time. Everybody probably hates cookies, which is why you're using the authorization header. So I'm going to show you why you hate cookies. Well, actually, first of all, they're handled automatically. The browser does everything for you with cookies, and I've marked that green because actually it's quite useful. It takes away a lot of the work that you need to do in other mechanisms. So that's one of the good properties. Of course, cookies are very difficult to secure. You have cookie flags like secure, HTTP only. You have a same site cookie flag now. You also have cookie prefixes. So you can actually attach a security prefix to the name of the cookie just to make sure that the browser handles it more securely. So in all honesty, it's a lot of effort, and you need to know a lot of these things to actually get that right, and that's a mess. That's why you hate cookies probably. But cookies are very compatible with the web, and they are present on all requests being sent by the browser. So for example, if you are sending an XHR request, that's kind of obvious that you can attach cookies there. But also if you put a script tag inside a page that's going to load a script file, the browser will send cookies with that request if he has some. And that means if you want to implement things like authorization checks on resources, on script files, images, stuff like that, that cookies actually work quite well. I've had this with one of our customers. They had admin features, admin scripts for their application, and they wanted to hide them from users that did not have admin rights. But that is very hard to do if you're not using cookies. And the second example is if you open a WebSocket connection, the browser is going to send a request to upgrade towards a WebSocket. There are going to be cookies on that request. So cookies work quite well. Of course, if you want to support them outside the browser, if you want to build a mobile app and you want to use cookies to access your API, it's going to be a nightmare. Nobody wants to implement all of these very quirky features that browsers actually do. So that's one of the drawbacks again. And finally, cookies enable something known as Crosssite request forgery attacks. So yes, cookies are a mess. Let's dive into Crosssite request forgery just for a bit, because I want to make sure that everybody knows what it is and everybody knows that you should protect your API if you are using cookies. And by the way, many people are using authorization header, but chances are that you're using a single sign-on service or an authentication service, which underneath still uses cookies. So cookies are used more than you might think, but maybe not purely for API access. Just a quick overview of what Crosssite request forgery is. I'm not going to go into detail. I don't have the time for that. So I'm just going to give you an overview of what happens in a Crosssite request forgery attack and why it's a problem. So if you have a backend and you have a browser, the normal interaction patterns are essentially you have the cookies which are set and sent. That's what's expected. In a C-server attack, you actually have a second context that comes into play. And the second context, in this case from example.com, is also not doing anything weird. So far, there's no attack happening. This is normal interaction patterns in the browser. However, this context can send a request to the backend of the other application. In this case, example.com is sending a forged request to the BeerSafe backend. And you can easily do that by, for example, constructing a form with hidden input fields and submitting that form that's going to trigger a post request to a backend from another domain. This has been possible since forever. That's a normal interaction pattern in the web, but it can be abused. And the real attack is that this backend is not aware that the request can come from anywhere. And that's essentially the problem with Crosssite request forgery. I mentioned you could do that with a hidden form, form with hidden fields, but that doesn't sound very API-like. So your API probably shouldn't be accepting requests generated by forms. And you're right, your API is going to accept other types of requests. You're going to send these requests with XHR, for example. You're going to build up a request with some data and submit that to your API. And if you do that, then you fall within the realm of CORS, or cross-origin resource sharing. And I know all of you have some experience with CORS, because it's a thing that gets in the way if you try to do something. And it's going to complain about missing headers and stuff like that. And what's really cool about CORS is that if you use CORS, if you have a cross-origin XHR request, the browser is going to attach origin headers to these requests. So the browser is going to send a request to the API, and it's going to say, wait, by the way, I'm being launched from within this context. The origin here on top is beersafe.eu, and the origin on the bottom is https example.com. So I'm coming from there. And this actually allows your API to check where a request is coming from and to prevent you or the API from accepting requests that should not be accepted. So if the API has no idea who example.com is, then he's probably not keen to accepting that request and processing it as if it's a legitimate request. And that's why CORS and C-server are actually quite related, and why it's so important to have a very tight, closed CORS policy. You don't want to, by accident, allow these things, because if somebody can send such a request, you are in trouble. There's one effective way to prevent that from happening. There's one way to ensure that requests to your API can only be sent with XHR, and that the origin header will always be there. That's essentially by creating a request that can only be sent from XHR using special features. For example, if you add a custom request header, the attacker will never be able to submit that through a form. This can only be done with XHR, and the moment you do it with XHR, the browser is going to step in and say, whoa, this is a feature that falls under course. I'm going to make sure that I add this origin header and check that the server actually wants this kind of thing to happen. And the second way to do that is using a content type that was never supported in a form before. For example, if you have application/JSON, there's no way to submit that with a form. So once your API actually enforces the use of such content types, then you will be sure that CServe is not a problem, even though you're using cookies in the backend. By the way, your API needs to actually enforce the use of the content type. Some backends are kind of flexible in that, so if you give them JSON data but with a text/plain content type, they still parse it as JSON and process it. And if you do that, then you still have a problem because forms can send text/plain data. Just a side note. So we started with this cookies and authorization header. Nobody uses cookies because of stuff like this. It's a nightmare. Cookies are very messy, but in all honesty, they have certain valid use cases. Let's talk about the authorization header now. Let's talk about the problems we see there. So the authorization header is not handled automatically. So I marked it red because you need to do some work. And the reason is, if you need to do some work, chances are you're going to make mistakes, which I'll talk about in the next slide. They don't have cross-site request forgery. So if you're not using cookies, if there's not something being attached automatically, then the root cause of CServe goes away, because the cause is that the browser attaches the cookie on outgoing requests. Not a problem here. Great. Unfortunately, the authorization header is not present on all requests. So the scenarios I described before, if you open a WebSocket connection and you use something in the authorization header, there's actually not going to be a header on that request for opening a WebSocket. So this means that you'll need to find another way of providing data there that you can use for authorization decisions. And that might be tricky, and that might require you to fall back to using cookies or to using a hybrid scheme with tickets and stuff like that. It's messy. It's easy to support outside the browser, of course. That's one of the big arguments if you want to use this header, so that's kind of obvious. And it seems easy to implement securely. And seems is kind of a keyword here. This is how you would implement that, by the way. This is an example of an Angular interceptor. I think Manfred is going to talk in a lot more detail about that this afternoon. What you see here is you have a request that's being intercepted. The request is going to well, it's cloned, you add a new header, the authorization header, and you add your token in there, which you get from your authentication service. Looks good, right? This is how you find this online in tutorials, whatever. However, it's not very secure. If you look at this, you'll see that it's attached to every outgoing request, which is perfectly fine if you use your own backend API. If you send requests to your backend, that's perfectly okay. Until a bit later, you actually want to implement a new feature that uses a third-party API. And the moment you do that, this interceptor is going to attach your session information to that outgoing request and is going to send it away. And you're leaking session information to third-party APIs. Hopefully APIs, maybe third-party services or whatever. And if one of these services sees that, they can of course use that data and impersonate a user to your backend, which is probably not what you want. So the real solution is to not attach it to every outgoing request, but check where you are sending it to and decide if you want to do that or not. This is an example from the Angular Jot library, which you can use to manage your the use of Geotokens in your application. And if you look closely, they have a configuration option just below the half called whitelisted domains. And that whitelisted domains option is actually a list of domains where you want to send your authorization header or attach an authorization header to. And that's a crucial way to prevent the leakage of information. So to sum it up, transport mechanism is more complicated than it might seem. Cookies seem messy and dangerous, but implementing things yourself with an authorization header may actually result in certain security issues that you have introduced yourself. That's, by the way, also why cookies versus tokens is kind of a nonsensical question, because tokens don't mean anything. Cookies are a transport mechanism. We'll see in a bit that cookies are also a storage mechanism, and tokens are just a way to represent session data. Let's talk about the last one, storage. Cookies are stored in a cookie jar, which is represented like a real jar here. So essentially, you have cookies that are associated with the domain. You can mark them as HTTP only, and then you're good to go. This is the easy part. The browser does everything for you. If you want to use the authorization header, then you'll have to do things yourself. And many people store information in the local storage area. Local storage is associated with an origin. In this case, it's https beersafe.eu, which means that any page in that origin will have access to that local store. Sounds easy, right? Well, one of the problems here is that once you have malicious code running in your origin, for example, if you have an insecure upload feature and the attacker manages to sneak code in there, it will also be able to read that local storage container. So one of the drawbacks of storing sensitive information there is that anyone who runs code within your origin can read that. By the way, this is an attack scenario. If you run multiple applications within the same origin, then they all share the same local storage area. So they all have access to each other's data, which is maybe not what you want. There's a second option, which is called session storage, which is like the lesser-known brother of local storage. It's in the same specification, and what it does is actually, it looks like it does the same thing. It's associated with an origin, but a session store is coupled or linked to a browsing context and its children. So essentially, it's linked to this browsing context. If that context opens a pop-up window, that pop-up window or that new tab, which is related, will also have access to the same session store. But if the attacker comes around with this insecure upload and he uploads a file and he loads that in a new browser window or a new iframe or whatever, that page is not going to have access to the same session store because session store is linked to one open tab or window and not to the entire origin. So the attacker will have its own session store, but he will not be able to access your session store. So essentially, these two options, you can use them to decide where to store your tokens. And it's going to be a trade-off between usability and security. By itself, a session store is maybe a bit more secure, but if the user opens a new tab, types beersave.eu again, it's going to have a separate session store. So you'll be logged out again, which may not be what you want usability-wise. By the way, there are applications using this. MailChimp, mailing list manager, actually uses a mechanism like this, and you are effectively logged out if you open MailChimp again in a new window. Of course, the local storage is more user-friendly, but has a bit more security consequences if you have other code running in your origin. That brings me towards the conclusion. I'm going to give you an overview of different scenarios and what matters, so it's not done yet. Stay around, please. But this is show you that session or cookies and tokens and stuff like that it's actually a lot more complicated, and that it matters, and that these properties actually have a lot more impact than you might think. So like I said, I have a couple of overview scenarios to show you what's possible and what matters. If you have any more questions about this, I'll be here the rest of the day, so grab me and ask me your specific scenario. So the first one is traditional cookie-based session management with server-side session data. That's what we've been doing for 20 years, and that you can actually still use with Angular applications today if you want to. Second option is using custom session management, the authorization header, for example, but also with server-side session data. And here you store it on local storage as an example. It doesn't really matter too much here for this overview. Third option, cookies, but with client-side session data. Nobody prevents you from putting a JOT token inside a cookie on the client. That's a perfect valid scenario. And you can also do, of course, custom session management with client-side session data using local storage. So one of the things is, if you are using server-side sessions, you need to handle your server-side sessions well. You need to implement something like sticky sessions to make sure requests go to the right server, or you need to replicate session data across different servers. This is one of the reasons that people are moving away from server-side sessions, because they don't like doing that. And if you're a massive application and with millions of users and you need to scale up like crazy, then this actually is a serious problem, and this matters. But if you're building a small application, if you have 100 users and you have one server running that application, then there's nothing stopping you from using server-side sessions. So think about whether this is a good match for you or not, because sometimes it actually is a good match, and it's a lot easier than starting to deal with JOT tokens, local storage, and the header and stuff like that. So this is a valid pattern even in Angular applications. Maybe this is not a popular opinion, but I'm a security guy, I don't care. This is a valid use case. If you have client-side sessions, that's again a valid use case. If you have client-side sessions, you need to ensure that you have integrity protection. You need to test that this actually works. And you need to think about how you want to handle revocation. What happens if a user, his account is compromised? How will we prevent existing sessions from being used? Things like that are not easy. Things like that are discussed among experts, and even they don't agree on how to do that. So if it's that complicated, you might want to consider how you will deal about that or with that in your application. Cross-site request forgery, we talked about that. That matters for cookie-based session management because the browser attaches cookies automatically. There are two ways you can do that. You can use or force the use of XHR and CORS because then you have an origin header to actually prevent or check where the request is coming from. There's also more traditional mechanisms. Angular supports a built-in CServe defense, but that's not for pure APIs. So if you want to know more, talk to me after the talk. If you're using a custom session management mechanism that you have implemented yourself, check what you do with data leakage. Check that you don't send your session data just about everywhere, because that's a potentially very dangerous pattern, especially if you don't have something with revocation in client-side sessions. Then you are essentially setting yourself up for failure. By the way, use libraries. Libraries often have gone to the same problems and have been fixed by their creators, so that's always a good place to start when you have to implement something like this. Then the final one, I want to tell you to compartmentalize your applications. We talked about the impact of malicious code running in your origin, being able to read your local storage. I believe one of the most important things that we need to start doing in the coming years is to actually build front-end architectures. Stop throwing HTML, CSS, and JavaScript in a pile and throw it at the browser and hope everything works. No, think about your application, think about sensitive parts, and isolate them in a separate origin. The browser will separate these things for you. If you deploy them in different origins, then the browser can do that for you. So think about these things and don't mix trusted content with untrusted content, because eventually your front end is going to be so important that that's going to lead to problems. That's everything I had for now. I only got 30 minutes, so I have 4 minutes left if you have any questions, but probably the organizers want to make up some time to end on time tonight. So my message to you is actually take security into account, build secure applications, follow experts like myself or other people to stay up to date on security information, and most importantly, share your experiences. If you do something for security, if you build your front-end architecture, I would love to see you here next year to give a talk about how you address these problems and how you made your application better, because that's what's going to help everybody else to build better and more secure applications. Thank you.